Section 8 of The Science, History of the Universe, Volume 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Fred Abood. The Science, History of the Universe, Volume 1. Edited by Francis Rolt-Wheeler. Astronomy. Chapter 7. The Solar System. The Motions of the Planets. The motions of the planets also formed the basis for archaic theorizing. That the planets move, the ancients were fully aware, for the very word planet means wanderer. The strip of the celestial sphere through which moved the sun, the moon, and the 5 planets known to the ancients, Mercury, Venus, Mars, Jupiter, and Saturn, was called the zodiac, because the constellations in it were named after living things, with one exception. The zodiac was divided into 12 equal parts, the signs of the zodiac, through one of which the sun passed every month, so that its position could be roughly given by stating in what sign it was. The stars in each sign were formed into a constellation, the sign and the constellation each receiving the same name. The relative movements of the planets, as the ancients conceived them, are thus summarized by Berry. In Pythagoras occurs perhaps for the first time an idea which had an extremely important influence on ancient and medieval astronomy. Not only were the stars supposed to be attached to a crystal sphere, which revolved daily on an axis through the Earth, but each of the 7 planets, the sun and moon being included, moved on a sphere of its own. The distances of these spheres from the Earth were fixed in accordance with certain speculative notions of Pythagoras as to numbers and music. Hence, the spheres as they revolved produced harmonious sounds, which specially gifted persons might at times hear. This is the origin of the idea of the music of the spheres, which recurs continually in medieval speculation and is found occasionally in modern literature. At a later stage, these spheres of Pythagoras were developed into a scientific representation of the motions of the celestial bodies, which remained the basis of astronomy till the time of Kepler. Philolaus, the Pythagorean, who lived about a century after his master, introduced for the first time the idea of the motion of the Earth. He appears to have regarded the Earth, as well as the sun, moon, and 5 planets, as revolving around some central fire, the Earth rotating on its own axis as it revolved, apparently in order to ensure that the central fire should always remain invisible to the inhabitants of the known part of the Earth. Although pure fancy, the idea of Philolaus was a valuable contribution to astronomical thought. Despite the immense influence of the Pythagoreans, most Greeks shared Plato's idea that any careful study of celestial motions was degrading rather than elevating, for the whole subject smacked too much of the unaesthetic section of geometry. Still, Plato, 429 to 347 BC, did give a short account of the celestial bodies, according to which the sun, moon, planets, and fixed stars revolve on 8 concentric and closely fitting wheels or circles around an axis passing through the Earth. This idea of Plato's was more or less followed by later philosophers. Thus, Eudoxius of Cnidus, 409 to 356 BC, attempted to explain the more obvious peculiarities of planetary motion by means of a combination of uniform circular motions. The celestial motions were to some extent explained by means of a system of 27 spheres, 1 for the stars, 6 for the sun and moon, 20 for the planets. There is no clear evidence that Eudoxus made any serious attempt to arrange either the size or the time of revolution of the spheres so as to produce a precise agreement with the observed motion of the celestial bodies, though he knew with considerable accuracy the time required by each planet to return to the same position with respect to the sun. In other words, his scheme represented the celestial motions qualitatively but not quantitatively. Aristotle adopted this scheme of Eudoxus, but needlessly complicated it by treating the spheres as material bodies and added 22 more spheres, thus making 56 in all. He argues against the possibility of the Earth's revolving around the Sun on the ground that there ought to be a corresponding apparent motion of the stars, an objection finally disposed of only during the 19th century, when it was discovered that this motion can be seen only in a few cases because of the unutterably great distance of the stars. No substantial advance can be noted until Hipparchus, 160 to 125 BC, made an extensive series of observations with all the accuracy that his instruments would permit, and critically made use of old observations for comparison with later ones, so as to discover astronomical changes too slow to be detected in a single lifetime, an essentially modern method. He systematically employed a geometrical scheme, that of eccentrics and epicycles, for the representations of the motions of the sun and the moon, a mode suggested in substance by Apollonius of Perga, who flourished in the 3rd century BC. The great services rendered to astronomy by Hipparchus can hardly be better expressed than in the words of the great French historian of astronomy, Delambre, who is in general no lenient critic. When we consider all that Hipparchus invented or perfected, and reflect upon the number of his works and the mass of calculations which they imply, we must regard him as one of the most astonishing men of antiquity, and as the greatest of all in the sciences which are not purely speculative, and which require a combination of geometrical knowledge with a knowledge of phenomena to be observed only by diligent attention and refined instruments. The last great name encountered in tracing the record of changing conceptions of planetary motions is that of Ptolemy, 100 to 170 AD, whose reputation rests on his Almagest, which may be regarded as the astronomical gospel of the Middle Ages. Hipparchus, as we have seen, found the current representations of the planetary motions inaccurate and collected a number of new observations. These, with fresh observations of his own, Ptolemy employed in order to construct an improved planetary system. Following the idea of Hipparchus, Ptolemy thought that the sun and moon moved in circular orbits around the Earth as a center. Ptolemy's chief work was to expand the system of epicycles so that it could explain discrepancies between theory and observation, discrepancies overlooked or ignored by Hipparchus. The deviations of the planets from the ecliptic, for example, were accounted for by tilting up the planes of the epicycles. Thus, with the aid of the system of Hipparchus, supplemented with his own idea of tilting epicycles, he worked out with great care and labor the motions of the planets. Although the Hipparchian Ptolemaic doctrine was framed on an extravagant estimate of the importance of the Earth in the scheme of the heavens, yet it must be admitted that the apparent movements of the celestial bodies were thus accounted for with considerable accuracy. For 14 centuries, the Almagest was regarded as the final authority on all questions of astronomy, and it may be considered as the loftiest piece of calculation appertaining to the ancient world. End of section 8.